As the population increases, we're going to need more crops, we're going to need more production, and there's only a limited supply of fertiliser and energy to create that fertiliser. So we really need a more sustainable way of farming, and one of those ways is through farming pulses. Pulses originate from the Middle East, and SARDI does a lot of work adapting those varieties into Australian conditions and for Australian farming systems. We work on things like disease, yield, improving weed control options, agronomic traits, how to integrate them into our seeding systems and work them in our rotations, and how to best utilise their nitrogen fixing capabilities within our intensive farming systems. Nitrogen makes up 78% of the composition of the air that we breathe around us, but what's available in the air isn't available in the soil for the plants. So there's two ways that farmers can get that back into their soils. You can use your commercial fertilisers, or you could use the natural source of sunlight. Pulses have a unique ability to fix atmospheric nitrogen, so they work in a symbiotic relationship with Rhizobia bacteria, and by doing that they're able to use sunlight to turn atmospheric nitrogen into ammonium nitrates, and that soil nitrogen then becomes available to all the soil microbes, the plants, and subsequently later down the food chain, us. SARDI does a lot of research in the glasshouse, looking at how that relationship works in pots, as well as field work to see how that expresses then in field in different soil types. And then we can see how that's best going to work in a real life farm situation. So in this experiment here, you might see different levels of greenness, and that might show how well the plant is or isn't converting that atmospheric nitrogen to an available form. So where they're a bit yellow, that relationship might not be going so well, and by not being able to convert that nitrogen, it's therefore having effect on the general health of that plant. So this is a plate of Rhizobia, which is a bacteria that works in union with the pulse plant to fix the nitrogen. So commercially, this bacteria is found in a bag of inoculant which the farmer buys and spreads over the paddock with the seed. So farmers apply inoculant onto their pulse seed at time of sowing, and that then provides the infection which allows the symbiotic relationship between the Rhizobia and the pulse crop to commence. That then forms nodules on the root hairs of the pulse plants, and on those nodules it has a unique ability to pull nitrogen from the air and turn it into an available source of nitrogen for the plants. So here we can see the root of that pea plant, and you can see those little bumps all around. Those are the little nodules. So those are the actual nitrogen factories of the plant that turn our atmospheric nitrogen into a plant available form. So the plant provides the bacteria with energy, and the bacteria provides the plant with nitrogen. This is great for sustainable farming systems because it reduces the need to use expensive man-made fertilisers, which require high temperatures of up to 550 degrees and high pressures, around 200 times the atmospheric pressure, to do the same job as these tiny Rhizobia. Not only does that reduce the fertiliser cost in the year of growing the crop, but in the next year when you're following that with a wheat crop or a barley crop or something, it also reduces the amount of fertiliser you need in that year, which ultimately reduces our entire carbon footprint and the costs on the farm. In addition, by using pulses in those sustainable farming rotations, you can also reduce your disease pressure, your weed pressure, and by doing that, the farmer's going to have less input costs, a more sustainable agricultural system by using renewable resources, and better soil health.